Okay, listen here, listen. What is this Markovnikov rule statement? To the unsymmetrical alkene, adding molecule. This is adding molecule now. In this adding molecule, we have one positive part and negative part, right? So the negative part of that adding molecule goes to least number of hydrogen containing carbon. It means don't consider this carbon. Wherever you have double bond, that carbons you consider. These two carbons we have a double bond now. In that, which is having least number of hydrogens? There you add negative part. What is our negative part in the molecule? That goes to the least number of hydrogen containing carbon. What is this rule called? Even if you forgot this rule also, what is this thing you need to follow? Carbocation stability. ఈ మెకానిజం అబ్జర్వ్ చేసి ఇలాంటి స్టేట్మెంట్స్ ఇస్తారు. Okay, this is the easy way to write the direct product instead of writing all these mechanism steps in the exam. Okay, is this clear everyone? Okay, but concept is what? Carbocation stability. Okay, so now if I say anti-Markovnikov rule, what is the statement? The negative part of the adding molecules goes to more number of hydrogen containing carbon of that alkene. Is that clear? Okay, next let us do one or two questions. You need to tell me the product. Tell me what is the final product fast. Is it symmetrical or unsymmetrical? Unsymmetrical. I am adding HBr. So what? Tell me. Once again repeat the statement. The negative part of the adding molecule goes to the least number of carbon hydrogens containing carbon. See, this is the alkene carbon. We need to compare. How many hydrogens are there on this carbon now? 1. This side we have 0 hydrogens on this. So 0 is the least number now. So here what I should add? That's it. So what is your final product? Here Br, here H. That's it. Is this clear or not? This is what Markovnikov rule addition means. Okay, next one. We'll fast. Tell me fast. Where I should add Br? Like A, B. A position? A position? Okay. Fine everyone? Yeah. What is this addition called? Now the same statement, I mean Markovnikov rule, no? Now I am saying anti-Markovnikov rule. That statement applicable, I mean mostly that will be used when we are doing HBr with a H2O2 reaction. What I am doing? Same HBr only, but what is this extra mentioned? H2O2 under sunlight condition. Now here, what is the product formed? Anti-Markovnikov rule product. It means how it will be? Opposite of this. What to do? Tell me. Here what I should add? Br. Here? Perfect. Is this clear everyone? So you can write anti okay, this one Markovnikov solution. Next one. Here also you tell me. Fast ma. Here what I should add? Br. That's it. This is your anti-Markovnikov rule product. Okay, is this clear? If you are clear with these two statements, the next further reactions are easy for us to do the reactions in the simple steps. Next one, listen, hydroboration reaction. What is it? This is one of the favorite for NEET aspirant, I mean NEET examiner also. Hydroboration of alkenes. See, like this they will mention. Hydroboration of alkenes gives alcohols. What they will give? Alcohols in basic medium. In which medium? Once again, define it in a simple form. Hydroboration of alkenes in basic medium gives alcohols. Simple. You remember Markovnikov rule, anti-Markovnikov rule, right? So now tell me, this is symmetrical or unsymmetrical? To this we are adding hydroboration. We are doing hydroboration. Now here, tell me, what is our final product? Alcohol means to the given molecule we are just adding H and OH. What we are adding? H and OH. See, if I add OH, it becomes alcohol now. So what we are adding? H and OH. So now tell me, here Markovnikov rule means what? Wherever lowest number is there, hydrogens are there, there will add negative part. Let us say this is H plus, this is OH minus. So hydroboration of alkene product is similar to anti-Markovnikov rule product. One single statement once again. Hydroboration of alkenes product is similar to anti-Markovnikov rule product. Anti-Markovnikov rule means what? The negative part of the adding molecule goes to more number of hydrogen containing carbon. So which carbon is more number of hydrogen? The terminal one, right now? So there what I need to add? OH, that's it. This is your final product. Simple? Okay. Now, here what I should add next? Here. H, that's it. Okay. Next one. Fast. Tell me, what is the final product? Fast. Where OH? Anti-Markovnikov rule, no? Means negative part of the molecule should be added at more number of hydrogen containing carbon. Where do we have more number of hydrogens? A, B. B. So at B position what I should add? OH. Here I should add OH, here I should add H. Up to here it is clear. Next statement I am using here, see. This addition is cis addition or syn addition. What addition? Cis addition or syn addition. It means that H and OH you are adding now, that must be in the same plane. Cis syn means what? Same group, same side we studied now. So like that, both H and OH should be in the same plane. Either it should be either above the plane or they should be in the below the plane. Okay. Next one. Intamundu reaction lo, there we have seen intermediate is carbocation. Here there is no carbocation or no intermediate here. It is a single step reaction. It means what we will see in the single step reactions? Transition state will be observed. What is that? It is a single step reaction. So we can say them as concerted reaction. What is that? Concerted reaction. A four-membered transition state is seen. Transition state is formed. Four-membered cyclic transition state is formed. Okay. Next, is this clear up to here? Okay. Next here, what is the thing I have mentioned? Basic medium. So now what about acidic medium means? In acidic medium forms alkanes. What it will forms? Okay. It means this one, B2H6. Instead of saying B2H6, they may mention sometimes as BH3 also. No worries, like monomeric unit you can say. B2H6, acetic acid. See, this is acidic medium only now. Acetic acid, H plus ion like this. So what is the product formed? Alkane. So just remove double bond, put here one hydrogen, here one hydrogen. So simple alkane will be formed. What you did? Here one hydrogen, here one hydrogen. That's it. Okay? That's it. Done up to here? Everyone? Next. Oxymercuration, demercuration. See, in the short form I am calling this as OMDM. What is this OMDM means? Oxymercuration, demercuration. See, like this we have unsymmetrical or symmetrical. To this you are adding water in presence of HgOAc twice. OAc means it is an acetate ions like OCH3 twice. Okay? During this reaction we will also use NaBH4. Okay. See what we have here? Water is there, no? See, addition of water to alkenes, what is the product formed? Alcohols, perfect ma. So alcohol is a product form. When you are using this OMDM, like mercury is there now, that's why we are saying oxymercuration. Then next we will remove that mercury. That's why we are saying it as demercuration. So for the demercurating purpose only we are using this NaBH4. See, simple what you need to do is OMDM reaction follows Markovnikov rule addition. Which rule addition? So here also single step, otherwise you just write it as no rearrangement. No rearrangement. See, Markovnikov rule means where I should add OH and where I should add H. Tell me. A, B. B, what I should add? OH. That is your final product. That's it. This is the alcohol. H will comes here like this. Okay. But the thing you need to remember is from where this H is coming they will ask. Not from H2O but from this NaBH4. Okay. What I told you demercuration na actually mechanism జరిగేటప్పుడు ఏమవుతుందనంటే ఇక్కడ ఒక Hg అనేది ఇట్లా ఈ Hg ఇట్లా 3 member cyclic ring form చేస్తుందమ్మా. Next this water molecule will add on to the central carbon. Here what is the next connection? Here we have this bond with Hg. Now we need to demercurate, now we need to remove Hg now. For that purpose what we are using? So that's why this NaBH4 will provide this hydrogen. Okay, OH from water, H from NaBH4. Is this clear everyone? Okay, next one. Tell me, what is the product formed? Same. Instead of saying this acetate ion, they will say like this, OAC. So what is the product formed? Fast. Where OH? AB. At A position, OH. That's it, no? Okay. So what I used here? Instead of using H2O, I can also use alcohol. What I can use? Alcohol. When I use water as my nucleophile, product formed is alcohol. When I use water, what is the product formed? Alcohol. If I use alcohol as my nucleophile, product form is ether. What it will forms? Ether. So how can you get that? Same. ఇక్కడ H2O నుంచి ఏం యాడ్ చేసామమ్మా? OH. ROH నుంచి మనం ఏం యాడ్ చేస్తున్నాం ఇప్పుడు? OR. That's it. See, OR. ROR. It means it is an example of what? Ether. That's it. Is this clear? Next. Okay. See, in the exam they will mention like this, Cl2H2O, or this Cl to H2O reaction provides you HOCl. What it will provides? So they may mention like this, or they directly give like HOCl. Out of these two, which is more electronegative, tell me? Oxygen. So it means it will breaks as OH minus and Cl plus. Now tell me, same, what to do? You add these two parts onto this double bond. So where I should add OH, where I should add Cl minus? Same. First electrophile add చేయండి. So what is that rule? Markovnikov rule. So Cl should be added at AB. Tell me. B, here it's Cl, here, that's it. Wait. See, okay, listen here. What is the positive part, ma? Okay, so if you add this, where I should add? If I add here, we'll get a secondary carbon, secondary carbocation, which is more stable, right now? Here if I add Cl, what is this? Secondary. If I add here chlorine, positive charge. Which carbocation is more stable? That one or this one? A or B? B is more stable now. So follow this. OH minus. Where it will goes? Here. That's it. So here it will be OH. Here it will be Cl. Okay. Now tell me. For this. HOX. X plus. Fast. First cation add చేయండి. First you add cation, generate a more stable carbocation. If I add X here, we'll get a tertiary carbocation. If I add X here, we'll get a secondary carbocation, which is stable. So it means where I should add X? A, B. A, perfect. X here, positive charge, OH. Perfect. Everyone got this? That's it. Okay. Next reaction is, listen this, ozonolysis. It means what we are doing? We are adding ozone to alkene. What we are doing? We are adding ozone to alkene. So this is very simple. Just follow me what I am saying. If alkene is given, ozone is given. Just break this double bond. After breaking, to this carbon you give one oxygen, to this carbon you give one oxygen. Here what about this? Zinc now. How many oxygens are there with us? 3. Give one oxygen to the alkene carbon. Here one. Remaining oxygen to this zinc. Now what is the product form? Tell me. CH3. CH. Double bond is there now. As it is you write. Breaking now. Put one oxygen. Plus this side. CH. H. Double bond. O. Plus zinc. Oxide. That's it. This is your final product. Okay. Now tell me again here. Instead of saying zinc, sometimes they may give you like DMS, dimethyl sulfide. Dimethyl sulfide indicated like this. Dimethyl means 2 methyls. Sulfur, sulfide. Yeah. Tell me what is the product form? What I told you? Break. O here, O here. Like this. This side. CH3. See, this line I have written like this. There is nothing means what we have here? Hydrogen. Hydrogen as it is. Here. Oh, that's it now. This is your final product. Plus DMS is there, one oxygen becomes DMSO. CH3 twice, S and O. That's it. You got how we are breaking these double bonds? That is your final product. Okay. Now tell me, alkenes upon treating with ozone in presence of reducing agent like zinc, DMS will act as a reducing agent. Once again, alkenes upon treating with upon ozonolysis gives you what? Aldehydes, ketones. Next one is called ozonolysis in presence of oxidizing agents. Here what I used? Reducing agents. Now I am using oxidizing agents so that I can call it as oxidative ozonolysis. What is that? Ozonolysis. So okay, same. Same ozone I am writing, but here I am writing H2O2 and H2O. What is this? Here H2O2 is there now. This is oxidizing agent. Now what it will do is same. You break the bond like this. First step is what? Break that double bond. After breaking, if this like alkene carbons are there now, to that if any directly attached hydrogen if present, convert that into OH form. It means, do we have any directly attached hydrogen this side? No. So don't disturb anything. You just write CH3, CH3, breaking. After that, what I should put? Oxygen. This is fine from this side. From this side, you break CH3. What about this hydrogen directly attached now? Convert into OH. Now what are the products formed? CO, CH3, OH plus this side CO, CH3, CH3. That's it. Is this clear? Now what is the name of this product? Acetic acid, like carboxylic acid. What about this? This is called acetone. Acetone, example of ketone. Where you use this acetone? You put nail polish for that removal. Okay, next this one, vinegar. Okay. So during the, in the exam, they won't mention the products. They will ask you the names. For example, the product formed X and Y during the ozonolysis of this alkene will be. Here, what are the products? Acetic acid, acetone. So oxidative ozonolysis gives you carboxylic acids, maybe aldehydes, not aldehydes, ketones. Okay. Next one here you can see. This is last example. Tell me, what is the product formed fast? What to do first? Breaking. What is this? Zinc. Reduction or oxidation? So it means ketones, aldehydes. So break this. O, H, H. This side. R, R. Here you tell me. This RR as it is. For this one, OH, OH. Okay, this OH is there now. Now this compound on the same carbon, if two OH groups are there, it will be less stable. It will try to decompose. How it will decompose? See, CO2. What is this? CO2, OH and H. H2. Like this they will mention. Instead of mentioning this carbonic acid, they will mention CO2 and H2 also. Is this clear, everyone? Okay. So ozonolysis is oxidation or reduction? Ozonolysis is oxidation or reduction. Finally, what you are doing to the compound, to the alkene? Addition of oxygen. Addition of oxygen means what? Oxidation. So ozonolysis is an example of oxidation reaction. So now there are some other examples for oxidation. See, alkenes. Like there is something called Bayer's reagent. What is that? What is Bayer's reagent? Alkaline dilute KMnO4. Alkaline means okay, KMnO4, dilute KMnO4. Okay. So now what happens is, whenever you see Bayer's reagent or this dilute KMnO4, just remove double bond, insert one OH here, one OH here. So what is the final product? OH, OH. So the same product will also formed when you are doing with osmium tetroxide. Osmium, both will give this kind of product only. Okay. Now tell me one simple reaction I will tell you here. What I should do? Remove double bond. Next, OH here, OH here. Again, addition of two OH groups you are doing now, that should be cis addition again. It means both OH groups should be from same plane, either above the plane or below the plane. Both should be from same planes. Like this you can write, or like this also you can write both. Okay. So what is this? Cold KMnO4 is a cis hydroxylating agent. What is it? What do we mean by cis hydroxylating? Like alkenes upon treating with dilute KMnO4 giving you cis diols now. See, cis diols means 1, 2. How many OH groups are there? Diol. How it is? Cis now? Cis 1, 2 diol. Okay. So dilute KMnO for Bayer's reagent is a cis dihydroxylating agent. 2 hydroxy groups it is making now. So that's why we are saying cis dihydroxylating agent. Okay. So now same KMnO4, look at here, once again I am saying same KMnO4, here hot condition, hot KMnO4 I am saying. There it is cold dilute. Here what it is? They may mention hot KMnO4 or simply they will mention KMnO4 in acidic medium. KMnO4 in acidic medium or heating condition they will mention. So now what you need to do is, just I am rewriting the structure for understanding purpose. This is alkene only now? Yeah. As like we did for ozonolysis, you need to break the bonds here also. We'll write it with a little bigger size. Okay, like this. Same story. Here, first you break these double bonds, put O, O. After that, to the alkene carbons, if there is any directly attached hydrogen is present, convert into OH. If any alkyl group is present, don't disturb it. It means what happens, you tell me this side and that side. This side carbon you tell me. C, double bond is breaking, so O. Hydrogen directly attached, OH. Methyl group is there as it is. This side C, this side double bond O, this side OH, OH. If on same carbon more OH groups are present, remove water. So CO2, CO2, H2. So now what is your products here? C, H3, C double bond O, OH plus CO2 plus H2. Clear? Now tell me, what is the product in this case if I ask for the same reaction? How you will break? Break the double bond. Okay. 6 carbons are there now. So write. Try to imagine what I am doing. Okay. This double bond you are breaking. 6 carbons are there or not in this ring? So here O. This side hydrogen I am putting here. Here O. If this directly attached hydrogen is there, means how it will convert? This becomes OH. What about this? This methyl group now as it is. So this is your final product. You got what we are doing? Just break చేయండి అమ్మా ఈ బాండ్ని. బ్రేక్ చేసి ఏం చేయాలి? డబల్ బాండ్ O up and down. Next, if there is any directly attached hydrogen, OH. If alkyl group directly attached, don't disturb, keep it as it is, that's it. Next, you just tell me what is your answer for this first step. What to do? Break it. What is the product? X and Y. CH3 CO what? Zinc. So what I should do? H or OH? That's it. So acetone plus formaldehyde are your X and Y's. The next step, if you see, dilute NaOH, this is there. We'll discuss in aldol condensation. Like this is an aldol condensation. We'll discuss in aldehydes chapter. Then you will get the answer there. Okay. Next. See, all the reactions are summarized here. Here you can refer it. See, all these slides are here only. I don't know whether you are referring or not. All the reactions are summarized here for your reference purpose. You can see them after the class. Okay. Next one, alkynes. When it comes to alkynes, one of the very important factor is their acidic nature. See, what is the hybridization of this carbon, ma? sp. Okay. What about this carbon? sp3. Which is having more S character? So this is 50% S character, na? So due to more percentage of S character, the attached hydrogen is there, na? That is acidic. What it is? Acidic. So alkynes directly attached hydrogens are more acidic than alkenes hydrogens and alkanes hydrogen. So this is more acidic. Okay, out of alkenes, alkanes, alkynes, which hydrogen is more acidic now? Alkyne hydrogen. Okay, so this side also hydrogens are there now, means no, this is not an alkyne hydrogen, this is an alkane hydrogen. So these are not acidic. If hydrogen atom attached to the sp carbon, then we can consider it as a acidic. Is this clear? Okay, next one. Okay, now what about acidic strength? Different groups are attached. Which group makes it more acidic? Withdrawing group or releasing group? Now here they will make a question here also. There is a possibility to ask. Yeah, A, B, C. Which compound is more acidic? A. Why A? Electron withdrawing group. That makes it to be more acidic. There is only alkyl group, here bigger alkyl group. So B. So A, B, C. So this is acidic strength. Everyone clear with this? అర్థమైందా కాలేదా? Okay. Next one. See, they will give like this. Alkyne is provided. Again, important reaction for both EAPCET and NEET. Look at here. Alkynes, with what they have provided? Water. If sometimes they won't mention water, they will mention dilute sulfuric acid. Dilute means water is added, no? Dilute sulfuric acid with what? HgSO4, mercuric sulfate. So what will be the product they will ask? Okay, see, What I told you, when there is acid, it contains H plus, dilute means OH minus. So you are adding H plus OH minus to this alkene. So where I should add, what will attack here? See, pi electrons are there means nucleophiles or electrophiles? So nucleophiles means what we should add first? H plus. So where I can add out of these two? Middle carbon or terminal carbon? So which terminal? I mean A, B, C, 1, 2. Tell me. And one carbon or two carbon? One carbon, what I should add? Here hydrogen. And this carbon, what I should add now? OH. Like this you are adding. Malli rastunna. C H CH3. See, triple bond is there. I removed one bond, one pi bond, so that I can add H plus. Where I should add H plus? This carbon. Why on this carbon? Because positive charge here is relatively stable. Because it is a releasing group, can stabilize this carbocation. Then next, what I should add here? OH. OH. Do you remember keto, like tautomerism? What is a tautomerism means? Proton transfer. Generally 1, 3 I told you. See 1, 2, 3. See from here to here I am transferring this proton. For that, what I am making, see, like this. Lone pairs are given this side means how many bonds it is becoming for the carbon? 1, 2, 3, 4 are there. This is the fifth bond. It cannot hold 5 bonds now. So one of this bond will shift here. So now what happens? CH3, C, O, already 2 hydrogens are there. This bond is coming here means negative and this H plus positive. So they will also make one bond now. H. Like this. ఇప్పుడు మీకు ఇది గుర్తుకు లేదు అర్థం కాలేదు అనుకోండి I will tell you how to remember this. What we are adding to this alkyne? H2O. So on one carbon we need to add H plus, other carbon we need to add OH. H plus and OH minus. First you decide where to add H plus? Terminal, this one. After adding that, H plus, here you have positive charge now, there you are writing OH now, directly you convert that into double bond O. If you are converting that double bond O, ఇంతకు ముందు ఇక్కడ డబల్ బాండ్ ఉంది కదా దాన్ని సింగిల్ బాండ్ లాగా రాసేసి అక్కడ ఒక హైడ్రోజన్ రాయండి. Once again, one more example we'll take. Tell me what to do. Where I should add H? Terminal. So second carbon becomes no? Here you are adding one hydrogen, here you are adding OH. So that what I told you, make it double bond O and add one hydrogen here, that's it. So what is the final product you are getting? Alkynes upon hydrolysis? Aldehydes, ketones. Aldehydes, ketones. Okay, all alkynes gives you ketones. What I am saying, all alkynes gives you ketones except acetylene. Acetylene means this one, ethine is there now, this is called acetylene. So just tell me what is the product formed here, how to write? So tell me what is the product formed? One carbon H, other carbon OH. Tautomerize it. C, double bond O, hydrogen this side, this will become 3. You put just balance that. So this is what? Acetaldehyde. It is an aldehyde. In remaining all cases, what I am saying? Ketones. Okay, that's it. Remember this. Okay, one last reaction. With this, everything is completed from alkynes. You just tell me what is the first product found for the first reaction. I mean, just now we discussed. Which aldehyde out of these options? Match them fast. A 3. This one, okay, you haven't studied about this. Yeah, you tell me about this then. What they are doing? Alkene with ozonolysis, breaking this. So what is the product name? Acetone. Okay. Next one, hot KMNO4 in acidic medium. What happens to the alkenes? Double bond, break it, put OO here and here. If any directly attached hydrogen, OH. Next, what is that product form? No? CH3COOH. Where do we have? Clear everyone? Okay. Now, methane oxidation in presence of molybdenum oxide gives you formaldehyde. What it gives you? Formaldehyde. That's it. So, anyways, with other A, B, D options, you can find your answer. Tell me what is that? Whatever it is, you just check there. Okay. Next. You got it or not? Concept. Okay. Next. Look at this. Acidic nature. Just now you studied. Which is more acidic? Alkynes, like Sp. So it means which option is correct? First option or second option or which one? First option will be correct. Why? First option because Sp should be there. Out of these two, what I told you, if electron releasing group is there, acidic nature decreases. If withdrawing group is there, increases. No group is there, intermediate. Here no group, here releasing group. Less acidic, more acidic. That's it. Okay. Next one. You know aromaticity? Remember, from this, definitely one question again. Without this, there is no question paper, I can say. Okay. So now what is this aromaticity means? It's a special property of organic compounds. Which compounds? Organic compounds. First of all, these compounds should be cyclic. How it should be? Cyclic. And all the carbons present in that compound should be planar. What they are? Planar means what should be the hybridization? sp2 or sometimes it will be sp also. Okay, you put a star mark for this because there is some exception here, that is why this star mark. Okay, next thing is it should be cyclic, planar. Next condition is complete conjugation. What they should have? Complete conjugation of pi electrons. Okay. Next condition is they should obey 4n plus 2 pi electron rule. Which rule? 4n plus 2 pi electron rule. So just follow my discussion. After that you will do them very easily. See, I am writing this compound. First of all, tell me which is cyclic out of these two? B. Like that, first identify cyclic compound. Next one, hybridizations you check. What about these carbons now? sp3, sp3. If it is sp3, non-planar. So the next one is, what about this? Here cyclic, sp2, 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 sp2 is fine. What about these two carbons? So sp3 means don't say it is not aromatic, it's non-aromatic. Let us put one pi bond here also. Now what is this ring called? Benzene. So now first condition obeyed or not? Cyclic, everyone cyclic? Everyone cyclic? Okay. Next, second condition? Planarity. Either it should be sp2. Oh. See, on each carbon there is at least one pi bond is there, means definitely sp2. Right? sp2 means trigonal planar, so everything is planar. Complete conjugation means, yesterday what is that minimum criteria I told for conjugation? They should be alternate position. See, pi bond, sigma bond, pi bond. So conjugation is there or not? Again conjugation like this. Yeah, complete conjugation is there. Next, what is the next rule I am saying here? N value means n you can put either 0, 1, 2, so on, like that you put. For example, n equals to 0. What happens? 2 pi electrons it becomes. Put 6 pi electrons. Like that you will get some numbers. So here how many pi electrons are there, ma? 3 bonds are there, each bond. So 6 pi electrons are there now. So 6 pi means it is a Huckel number or not? This 6 pi electrons, this is satisfied now? Satisfied now. So all 4 conditions are satisfied. Ivanni satisfy ayinaya leda? Then you can say the compound is aromatic. If at least one of this condition is not obeyed, it is non-aromatic. Once again, if at least one of this condition is not obeyed, non-aromatic. Everyone clear? Okay. And the last one now. You put any value here. It can be 0, 1, 2, 3, 4. What happens now? Put 0. 2 pi electrons. Put 1. 6 plus 2. 4 plus 2, 6. Put 2. 4 to 8 plus 2, 10. Like that. If any of this number is coming here in the system, then you can say that system as aromatic. అర్థమైందా కాలేదా? ఇంకో 2 ఎగ్జాంపుల్ తీసుకుందాం. కూల్. I am writing like this. First of all, tell me compound is cyclic or not? Cyclic or not, everyone? Yes. Now look, what is the second condition? Planarity. This carbon is what? See now, this carbon, pi bond, please everyone listen, pi bond, sigma bond, negative charge, are lone pair. So is they are in conjugation or not like this? If it is conjugation, what happens to this negative charge? It becomes a bond now. This is as it is. See, it is shifting here means. So this negative charge carbon also becoming a pi bond. It means this is also sp2. All carbons are sp2 or not now. So sp2 means planar. Second condition is also done. What is the third condition? One conjugation you have seen like this. Next conjugation if you do, it will goes here. Again that will comes here. Like this complete conjugation is taking place or not? Yeah, 3 rules over. Fourth rule is what? How many pi electrons we have? See, this negative charge also becoming pi bond now. So count that also. 6 pi electrons are there or not? So 6 pi electrons are there means aromatic. Okay, like this. Everyone clear with this or not? Okay, you just tell me for this example. Fast, ma, we do not have time for slow discussion. Tell me for this. Compound cyclic. Next. sp2. Carbocation means also sp2. Complete conjugation is there or not like this. If it is shifting, positive charge will come here. Like that. Next, complete conjugation also there. Next one. 4n plus 2 means n value how much I can put? If n is 0, it becomes 2 pi electrons, right? So this compound is also what? Everyone clear with this? Next, one more example. Fast, tell me fast. Cyclic, conjugation, like this lone pair electrons. Ikkada negative charge chusaru, ikkada lone pairs unnai. So they can also participate in the conjugation. 6 pi electrons, aromatic. Is this clear? Okay. Now what are the 4 conditions I told you for aromaticity? Okay. Next rule is same conditions, ma. All 4 conditions are same. All 3 conditions are the same. First 3. Instead of this, if it is having only 4 in pi electrons, how many pi electrons? 4 in pi means like n value can be 1 you put. What happens now? 4. 4 pi electrons. Or 2 you put 8 pi, 12 pi, 16 pi. Like that it becoming means that should be called as anti-aromatic compound. What is that? If it is 4n plus 2, aromatic. Followed these three statements, but this one, anti-aromatic. Clear everyone? Okay. Now, if none of these are followed, those are called non-aromatic. There are three statements now, three terms now. Aromatic, anti-aromatic, non-aromatic. Okay. So now tell me for anti-aromatic conditions. Clear everyone? Yeah. So now let us enter into the complete questions. Like I will do all the questions here. You just tell me which is aromatic, non-aromatic, anti-aromatic. You can also write with me otherwise. You should practice all this. Write fast. Right. Okay. Okay. Done? Write it fast. Okay. You can write. First one example I have discussed. This type of example I have given above. And next, from here, see, there is sp3 carbons, means non-planar, so non-aromatic. Out of this one you tell me, see, complete conjugation is the cyclic compound, aromatic this will be, okay. Next one you do it for this one, aromatic, perfect. Next one, this one, this one, cyclic, planar, how many pi electrons? 4 pi electrons, like 4n pi electron, 4 pi electrons. How many pi electrons, ma? So anti-aromatic. Next, this one, non-aromatic here, sp3. Next this one, already we discussed about that. Yeah, this benzene you do these two things. Next this one you tell me. Cyclic, plenarity, how many pi electrons? 6 pi electrons, so aromatic. Next, this one, sp3 carbon, non-aromatic. This one, so if you do, actually you feel it like anti-aromatic, no? So you write anti-aromatic and put cross, okay? So it will be having shape like, see, cyclic compound, how many carbons are there? 8 carbons are there, octa. How many pi bonds are there? 4. Tetraene, cyclo, octa, tetraene. In the short form I am writing it as COT, C-O-T, cyclo, octa, tetraene. So this compound exists like a tub. How it will be? Like this. So it's a non-planar compound. What I am saying, it's a non-planar. So if it is a non-planar, non-aromatic. That's it. What about this compound? This is naphthalene. Naphthalene is like aromatic rings are there. Benzene ring is there, no? At least one aromatic ring is there. Complete compound also aromatic. But you can consider this is aromatic or not. That is also aromatic. So complete compound is also aromatic. What about this compound? This is called anthracene. What is this? Anthracene. So anthracene also aromatic. Next, this one if you observe, it is similar to naphthalene but it is not aromatic. Why not aromatic? See, there is no bond here if you observe, like this. If it is a bond, itla bond undi anukonamma, ee atom ki bond, if there is a bond like this, it will stop like flipping and all, but there is no bond connectivity here. It means there is one hydrogen over here and one more over here. So between these two hydrogen, interactions will be there like this. So due to that interactions, one will go up, one will come down. So compound become non-planar. Here they are like connected like this, means it become overall molecule is planar. This is a non-planar. If non-planar, so non-aromatic. Next, what about this one? Same compound ma, but what they did here, this one and this one is connected like this. These two hydrogens are there, na? Just imagine I am catching the two hydrogens like this. Don't move here and there, you just say like this, means what happens now? Do they have any interactions now? No repulsions, nothing like that, no flagpole interactions. Like that, I catch this carbon and I connected here. Now what happens now? This compound, this carbon is sp3, that is fine. But is it in the plane? No. This is out of the plane, but remaining complete system? Aromatic system. So even though some compounds having sp3 carbon, but if it is not disturbing the conjugation, then the compound will be aromatic. Is this clear everyone? So this compound is also aromatic. Next, what is the name of this compound? Pyrrole. What is that? Pyrrole, just now I discussed above. What is this? It is also aromatic. Instead of having nitrogen, nitrogen 7th atomic number. 8th one is, if we have oxygen, this is called furan. What is that? This is also aromatic. Instead of oxygen, down, sulfur, you should call it as thiophene. What is that? All these are aromatic. These are 5-membered ring. Here I have 6-membered ring with nitrogen. You should call it as pyridine. What is that? So this is also aromatic. That's it. Next. Just answer me this question fast. Yeah, done. So ma'am is waiting outside. You just answer this and you can go.